Control structures and loops allow you to go through your code in a nonlinear fashion. Now, typically when I have some code like this, I'm going to execute these commands one after another. So I'll start my serial port, I'll set a pin mode, and I'll digital write that pin to low. Now, your loop function in an Arduino sketch is already one of these control structures that allows me to repeat this same chunk of code over and over, and we have other kind of loops that will do that same thing. So if we go to the Arduino reference page and we go down to control structures, we're going to go through if and if-else statements, we'll go through for loops, and we'll go through while loops. And obviously there are a number of other do-while, case switch statements are other interesting ones, but if, for, and while will really cover the basics of what you need. Now we'll start with if statements. So say up here I want to actually set another pin as an input. So I'm going to set pin 2 as an input, and pin 13 is my LED pin on the Arduino. Remember, it's connected to an LED on the actual Arduino hardware. And what I'm going to use an if statement for is to see if that input pin is high, or is 5 volts, then I want to turn my LED on. So in my loop function right here, I'm going to use an if statement, and I'm going to read that digital input pin. And so I could read it and put it in a variable is one way to do it, but I can also just do a digital read of that input pin right here, and I'm going to say if that is equal to high, right, which is a constant that I can use. And if you want to look at the comparison operators, they're down here in the reference. So a single equals is an assignment, so that's assigning a value to a variable. Double equals is saying, is this equal to, right? Obeying equals is not equal to, less than and less than or equal to are fairly self-explanatory. Okay, so going back to my code, I'm saying if digital read of pin 2 is equal to high. Remember, I always want to use these curly braces here, and as soon as I hit enter, it will add my closed curly braces here. Then I'm going to digital write that pin 13 also high. All right, and so I can upload this to my code, to my Arduino. And on my actual Arduino, I have this pin 2 connected to one of the ground pins right here. So right now, it shouldn't actually be giving me any LED signal, and if I look over here, I don't have an LED on. So if I turn that to 5 volts instead, now you can see, hopefully, that that LED is on. So once that if statement saw that the input was now high, it wrote high to the LED pin. Now, the problem with just this if statement is if I turn this back to ground, so now this is plugged into ground, that LED is still on. Right? So what I'm going to need is something a little more complex here. I'm going to need an if-else statement. So I can just go and add an else clause to this statement and say, if that pin is high, then I set my LED on, and else, which means it's low, I'm going to turn off that LED. So I'm going to write a low to my LED pin, and I'm going to upload that. And now I'm connected to ground. If I connect that to 5 volts, my LED turns on. If I connect back to ground, my LED turns off. And that's a basic control structure. That's a basic if-else statement. I can go to my reference page here as well and click on if-else, and it also gives me the syntax of that. So I can do more than one particular function in there as well. So I'm just saying I do action A if this is true, otherwise I do action B. So one thing that I might want to do just from a debugging standpoint is do a serial.println and say LED is on. And if it's off, I'm going to say LED is off. So I can upload this, and I can do the same thing by looking at my serial monitor. So LED is off. If I connect it now to my 5 volt pin, you'll get LEDs on, and I can tell you By looking at it, the LED is indeed on. If I turn it back to ground, now my LED is off and I'm printing LED off. So this gives you an idea of how you might want to use the serial port to help you debug code that you have on your Arduino as well. Another control structure or loop is a while loop. So if I click on while loops from the reference page here, this is going to tell me that while loops will loop continuously, indefinitely, until an expression here is deemed false. So while this expression is true, it'll continue looping through whatever's inside the while loop. So I can do that very simply. So this is continuing to print LEDs on or LEDs off. If I add a while 1 here, right, I don't have anything in my loop, but I add a while 1 and I upload that, what that's going to do on the serial monitor is it's only going to print that once now. Right? Whatever state it's initially in, now the code is stopped because it's just indefinitely in this little while loop. Right? So this loop function should be continuing to loop, but is stuck in this while loop, this while statement here. But more often, while loops are used to actually loop until a particular thing is true or until the condition inside of it is false. So a very good way to do this is similar to what we were doing with the if statement up here. I'm going to delete all of that, and I'm going to say while that digital read of my input pin is equal to low. Now I'm going to actually add something inside my loop. I'm going to serial.println waiting. Right? And once digital read 2 is equal to high, I'm going to serial.println signal is detected. Right, this is just an example of how you would use a while loop. Right, so I can upload my code, right, and if I go to my serial monitor, it's waiting, 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 and now if I take that pin, which is currently connected to ground, and connect it to 5 volts instead, it's giving me signal detected. Now an interesting thing here is that you keep seeing the signal is detected as well. So if I go back to what I actually have in my code, right, once I write signals detected, my loop function means I go back to the beginning of this. But in this case, digital read of 2 or pin 2 is connected to high, right? It's connected to 5 volts. So it reads high. So while digital read 2 is low, it's just not even true. So I never get into that waiting statement. So I never print that waiting statement, and I just print signal is detected again, right? And so I loop through that again, and if I finally get to a low again, right, I'm back in waiting. So this is just another way to branch your code or repeat your code. Okay, a final control structure that's useful is the for loop. And a for loop is most often used to go through a particular code a certain number of times. So if I go back to my reference page and I click on for here, right, the for statement is going to repeat a block. So it's a loop again. It's repeating a block of statements that's included in that curly braces, but in this case I also have an increment counter to increment and terminate the loop. So it's always going to be based on a counter. So this is a very common structure for a for loop. So I can use I can declare a variable in the loop that I'm using as my counter. So in this case I'm declaring variable x and initializing it to 0. This is my conditional statement. I'm going to keep looping while x is less than 100. And then finally this x++ statement means I'm going to increment my counter. I could also say start it at x equals 100 and x minus minus and continue going while x is greater than 0, for example. Right? And inside this I can do some actions. So I could, for example, do something 100 times in this case. Okay, since you just did multiplexers in your lab, what we're going to do with a for loop is use a for loop to increment through the various addresses of an 8-to-1 multiplexer. Okay, so in this case, I've initialized a loop variable, a loop counter, I is equal to 0. I'm going to continue to do this while I is less than numLoops variable. NumLoops I've declared as a global variable up here and set to 8 because I have an 8-to-1 mux that I'm assuming I have here. and then I'm going to increment I each time I go through the loop. So I'll start with 0, and it should start with a mux address of 0, and then increment that each time, so it should get 1, 2, 3, 4, 5, 6, 7. Once I get to 8, I'm no longer less than the number of num loops variable here, right? And then I come out here, I delay for half a second, and then because I'm in this loop function, I would repeat that. So let's go ahead and upload that code. Right, and we can open the serial monitor, and you'll see it prints mux address 0, 1, 2, 3, 4, 5, 6, 7. It does that every half second. It's going a little fast, so I could delay it a little longer if I wanted. Okay, but more importantly, I actually want to control some output pins depending on what this address is. These, for example, so let's say pins 2, 3, and 4 are connected to the address or selector pins on my multiplexer. So in order to do that, I'm actually going to use a number of if statements. You can do this in a much more clever way if you really dig into the Arduino reference code, but for right now I'm going to do a bunch of if statements. Okay, so here are all of my if statements. So in each case I'm checking if I is equal to 0, then I'm writing the equivalent of 0 address to those pins, so 0, 0, 0. If I is equal to 1, I write 0, 0, 1. All the way down to if I is equal to 7, I write 1, 1, 1 to those pins. I've added a delay after each one because I'm going to show you the output on some LEDs as well as the serial address each here. Right, I'm going to open up my serial monitor, and you can see it slowly ticking through those addresses now. And what you may be able to see here as well is I'm also slowly ticking through the outputs. So I start with 0, 1, 2, 3, 4, 5, 6, 7, restart at 0. So this is a way that I can actually control an output or count through a particular number of loops. In this case, I might want to do it in order to set some address pins on a multiplexer or a demultiplexer. But for loops, while loops, if statements, if else statements are going to be an incredibly useful part of your Arduino arsenal.